So we got a topology where we are going to see the IKE version 2 configuration of site-to-site VPN. IKE version 2. IKE version 2 has got a lot of things to do in phase 1. First of all, let us begin the basic IP address configuration and routing between the WAN side of the sites. The LAN side of the sites will ping only through the tunnel. So let's begin from the beginning. I'm in site 1. You can use Notepad or you can use straight away on the configuration. For your convenience, I'm going to do it on the configuration CLI. The configurations of the CLI. Enable config the hostname. I would like to name this as site 1. Interface loopback 0. Or let's do one thing. Let us keep one virtual machine to act like to act like an internal network. Why we need to use loopbacks? We can have VPC also. Let me try this. Will it be allowed to connect? This is the problem. I need to restart the router again. But it will be more realistic if we use this. So better let us stop these two guys and start from the beginning. So we got the internet router ready. Let's go and say enable config t interface G00. IP address 110.110.110.10. Oh, come on. 255.255.255. All right. Interface G01. Sorry. This is not sensitive. IP address 210.210.210.10. 255.255.255. I will wish to run OSPF IP OSPF 1. On both interface. Right. Now I'm going to site 1 to check whether the router is ready. Still not ready. Meanwhile, we'll fix the computers. These computers are going to have this IP address. This is what the IP address on the computer. And on the router, I would like to give .10. Yeah. Likewise, here I would like to give this as an IP address on the router .10. Right. We are in VPC4. We type IP space 10.1.0.1/24 mask, and the gateway is 10.1.0.10.1.0.10. Likewise on other computer VPC, IP is 10.2.0.1, mask is 24, and the gateway will be 10.2.0.10. Fine. Now let's go and check whether the router is ready. Almost getting ready. I've finished configuring internet. You saw me doing that. Let me do the site 1 and site 2 basic configuration with the notepad to save our time. As the routers are getting ready, we'll finish this configuration. Interface G0/1, no shared IP address 10.1.0.10. See here, I'm not enabling any OSPF on this interface because it's LAN interface. This interface will be having, for reachability to this interface, we'll have a static route because it needs to go through the tunnel. But nothing wrong in having routing protocol. But I don't want to do that so that just to show that internet do not know about this network. We're going to take the traffic, encrypt and encapsulate with 10, 10, 10, 1. Internet needs to know only 10, 10, 10, 1 and 20, 10, 20, 10, 20, 10. It need not to know about the LAN because LAN networks are not going to be revealed as they get routed. That's what we call tunnel. So there is no OSPF on gig 01, interface gig 00, 110, 110, 1101, IP OSPF. It is. That's it. This is what goes on router 1, site 1. Alright, on site 1 I have pasted the configuration. Let us go to site 2. On site 2 G01 IP address will be 10.2.0.10 and G00 is going to have 210. Paste it on site 2. Let us change the host name. Host name is site 2. This goes on router 2. I'm expecting OSPF neighborship with the internet because we already finished configuring internet. So the OSPF we don't need to put IP address, right? No need. This is another method of enabling OSPF. No need to put IP address. You need to go to the interface and enable. Okay, so from site 2, I'm able to ping the WAN interface of site 1. So internet is there. This is what we have simulated. In the, I configured that router. That was the first router I configured. Otherwise, how we will be pinging this? See, this is the first router we configured. Show IP interface brief. You see. Show IP route. You see. Show IP protocol. You see. OSPF. This is the first router we configured. You need to rewind this video and see. Host name INT. All right. So in the real world, we used to have reachability between site 1 and site 2. So that is already achieved. Now we need to go to the main part, the VPN part. All right. So show IP route. Even here you will have a route to reach 210.210.210 network. Let me ping and show you. Okay. See, for this LAN network, I want VPN. So what I'll do is I'll simply say IP route, a static route. If you want to go to any other 10 network, send the traffic to 110.110.11.10. Who is this? This is internet. I'm saying if you want to reach any 10 network, which means 10.2 is on the remote site. To go to the remote site, you need to go to the internet. When it tries to go to internet, it will take the interface G00. Do you agree? So this one, internet really don't know anything about this private network. These are all private networks. Internet don't know anything about private network. Private networks are not routable. Then why I'm sending it to internet? Actually, I'm not sending it to internet. When I say go to internet, it will try to use this path. The router will try to send via this path. When it is trying to send via this path, this is where I'll put the VPN tunnel, the crypto map. So it will take the tunnel instead of the physical. We are going to create tunnel on this interface. So when the when site 1 router tries to send it to route internet, it will touch the gig ethernet 00. Gig ethernet says go via tunnel, and it will go this way. So I need to write a static route on both the sites. On site 2 also I'll write a static route, IP route. I want to go 10 network. It also has got a 10 network directly connected, but we are talking about other 10 networks. Now, the ping will not happen. The reason is we don't have the tunnel. See, if I go to VPC4 and try pinging 10.2.0.1, the ping will not happen. The reason is the tunnel is not ready. Let's try pinging our gateway. Gateway, will it ping or not? The remote site. The remote site. I'm not in router. You see the heading. You see VPC4. I'm pinging VPC5. It won't ping. But if I ping my gateway, it will ping. Because it is directly connected. My gateway is directly connected. It pings this. Likewise, I'll go to VPC5 and ping the gateway. Just for testing. Now I want to make sure the gateway is reachable. And it is. Now let us form VPN. Are you ready? Where is the routing? We don't have routing from here to here. Where is the routing? There is no routing. Unless you put the tunnel, the routing won't work. Internet do not know about a network. In the internet, is there any route for a network? Then it will ping. See, pinging is not our aim. Our aim is to ping with encryption. The encryption will be done by site 1 router and site 2 router, which we call it as tunnel. So, site 1 will encrypt. See, listen carefully. This is your packet. This has got source address. When you ping from here, what is the source address? What is the destination when we ping this remote site? Yeah. When the packet goes here, the static route says you need to go to internet. When it tries to send it to internet, this interface says, wait a minute, I want to encrypt you. So it encrypts. And then it encapsulates with a new source address, which is this tunnel address, 110.110.110.1. And then this tunnel destination, 210.210.210.2. So all that this router needs to know is only this destination to reach. And internet knows it, and internet will send it. And here the decapsulation happens. After decapsulation, decryption also happens. And routers can see the site 2 can see the original destination. It delivers the packet here. Did you understand? So there is no need for routing in the internet. In the real internet, even if you try to have a route, it is not possible because it's a private network that you are having it in the LAN. 10.1 is a private network, 10.2 is another private network. Private networks are not routable in the internet. Next, we need to go to phase 1 configuration. I'll also paste parallelly to send it to you in a notepad, like as I was doing yesterday, but yesterday we stopped in the middle because of the power. Enable config T phase 1. In phase 1, crypto IKE version 2 proposal is what we need. Give a name, I'll say pro. No, it's okay, leave. We are doing fresh. Proposal. And then for encryption, we want some combination of protocols like 3DES, AES, maybe AES 128. And then for integrity, we want MD5 and SHA. In SHA, we want 1. And then for grouping, we want 2, 5. This is what we call as proposal. Combinations of protocol can be considered. Now next is we need to create a profile. Policy, before profile, policy, crypto IKE version 2 policy. I like to give a name as policy 1. And inside the policy, you need to call the proposal. Proposal name is, I gave pro exit. So far I have done show run crypto. I've done half of the phase 1 configuration so far. Half of the phase 1 configuration is over. Phase 1 is still not over, half is over. We created a proposal, we called it under a policy. I paste it here. Next. In phase 1, we need to create a key now. Key ring. IKE crypto IKE version 2 key ring. I'll call it as key. And then peer, how do you identify peer? I would like to name it as site 2. What is the address of the peer? The address of the peer is 210.210.210.210.2. Now, what type of pre-shared key we are using? Locally, I'm going to use Cisco 123. And remotely also they are using same. If they are using different one, you need to specify that here. But in our case, they use both same. Both use same. So next. I don't know. It depends on people. Some will say, "Hey, this is not necessary. Anyway, we are going to encrypt. Why we need to have different password?" This is some people's method. Some people will say, "No, no, no. We have an option. Let us use it." So either way, you will see it. Next. Crypto IKE version 2 profile. I'll say profile 1. Profile. I'll simply say profile only. Okay, in this profile, what are the things that we need to do? We need to specify the identity of the remote device. We have finished the phase 1 key ring. Now we are about to start the profile. So let me say crypto IKE profile profile as a name. In this profile, I need to match the peer. Match identification of the remote peer. The remote peer IP address. Here I can use the address. I can use email. I can use fully qualified domain name. I can use any key ID. Now I'm going to use address. The remote identification address is what? Can you say? For site 1, who is the remote? 210.210.2. Next is what sort of authentication method we are going to use. We are going to use pre-shared key. So I have to use the command authentication. Local is pre-shared key. Authentication, remote also pre-shared key. See, there's a big difference. Here we are not saying the password. Here we are saying the method of authentication. Earlier in the key ring, we said the password. If you see the notepad, earlier I created a keyring, where we say the password. I'll show you now. Next, the keyring name I gave is key ring local key. Now, what all we have done, let me show you. Do show run section crypto. Oh, spelling mistake. TO. Notepad. Done. See, this is what phase 1 means. We got a proposal, and the proposal is called under policy. Proposal is called under policy. Then we got a keyring. In the keyring, we gave the IP address of the remote site, and we say what password we are using. Whereas here, we are not saying password, we are saying what method of authentication. What method of authentication? Pre-shared key. This pre-shared key is what we have defined here. Next is phase 2. Phase 2 configuration. Let me save this for you. IKE version 2. Go. Now, phase 2 is crypto IPsec transform set tset and give a name. IPsec yeah. So that's the command, crypto IPsec transform set, and give any name. I say tset as a name, and then give any combination of encryption and hashing. I'm going to use for encryption this, and space. For hashing, I would like to use this. Now this I need to put it on. This I need to put it on the notepad. Next is the access list. We need to write an access list. Access list number, protocol, sorry, permit, protocol. Any traffic going from 10.1.0.0 to 10.2.0.0. Do you understand this access list? Okay. So this is also, it means that this LAN, when it tries to talk to this LAN, see this is in 10.1, this is in 10.2. When this LAN tries to talk to this LAN, it needs to go through VPN. So we are writing ACL for only this traffic. No other traffic will use VPN. They all use internet. So access hyphen list 101. Done. So access list after comes the crypto map. All right, let's go to the crypto map. The reason why we are running crypto map is we cannot assign the access list transform set and the IK version 2 profile under the interface. We need to put it in a crypto map and call the crypto map. We cannot directly apply it on the interface. So crypto map, give a name CMap, any number, I'll say 10, ISAKMP, IPsec ISAKMP. Now match address 101. This is access list. Set transform set. T set is what I gave. You see. Transform set name is T set. Access list is 101. That's what I have called now. Next, I need to call this profile. So I'll say IKE set IKE version 2 profile. IKE version 2 profile. IKE version 2 profile is this profile. And then one more is peer, set peer. Set peer, who is the peer? This is the IP of the peer. That's all. Let me show you now what we have done so far. After access list, I wrote only crypto map. So we'll copy the crypto map now. Show run section crypto. I made a spelling mistake. Crypto. What? CRYPTO. Okay. So this is what we need to copy to the notepad. All the rest are copied. The final step is the step of assigning this to an interface. So we'll go under the interface now. Which interface? Interface facing the WAN, interface G00. This is the interface which the channel will be using. So we say crypto map, CMap. I'm expecting ISAKMP to come out. Okay, good. It's a good sign. Now, I'm going to copy this. Okay, let me put interface G0/0 crypto map CMap. Done. So I'm going to copy this and alter it a little bit to match the other router on the remote site. Site 2, let's come from the top. Site 2, this will be, peer will be site 1 then. And then this address will be 110.110.110.1. Am I right? Yes. And then this identity will be again 111.110.110.1. Okay, what else? That's correct. That is correct. Local and remote is correct. Now, the transform set, okay, this one need to be On router 2, means site 2, 10.2 is the source. Destination is 10.1. Destination always comes second. First comes the source. And then this is going to be again 110. Now we'll copy this. Everything is perfectly matching with the requirement. Now let us go and paste in R2, site 2. All right, finally. Okay, now let us try pinging from site 2 to site 1. Ping 10.1.0.1. Sorry, let me ping from PC itself. PC5, ping this address. Oh wow, 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 wow. The tunnel is working, otherwise this ping will not happen. You know very well the internet don't know about N network. So go to site 2, you will definitely find a tunnel now. Show crypto IKE version 2 SA. Look at this. This tunnel is ready. It is ready between this local network and this remote network. And you see this 500 port number is ISA-KMP phase 1. And this is what the encryption algorithm used to negotiate. And this is the hashing algorithm. And this is the Diffie Hellman group. Authentication is pre-shared key. And authentication pre-shared key is verified. And everything is working fine. For 20... These two are hashing. Both are hashing only, hashing algorithm. Both are hashing only. MD5, you see this is also MD5. This is also MD5. Right now, let's see the encrypted packets show crypto IPsec SA. You can see packets, 4 packets encrypted. Let's ping more. I'll ping more, I'll ping more and more and more. Now I'm pinging 5 more, so I should see 9 packets. Earlier 4, now it is 5. Yeah, 9 packets encrypted and decrypted. The tunnel is working good. You may also try if you want from here. Ping 10.2.0.1. It pings very well. Now go to site 1 router and check. Show crypto IKE version 2 SA. It's there. Show crypto IPsec SA. You see 14 packets. Earlier 9, now it is another 5 packets, so totally 14 packets. Successfully completed IKE version 2 side-to-side VPN.